The signal from Andromeda, a cosmic revelation ***, the year is 2025 and the stars above seem to whisper secrets that humanity has only begun to unravel high above Earth's atmosphere. The James Webb Space Telescope JWST, a marvel of human ingenuity, floats silently in the void, its golden mirrors drinking in light from the farthest reaches of the cosmos for centuries. Astronomers have gazed at the Andromeda Galaxy, our nearest cosmic neighbor, with awe and curiosity, known as M31, the spiral light 2.537 million light-years away has long been a mirror reflecting our own Milky Way story, but now JWST has detected something extraordinary, an alarming signal emanating from Andromeda's core, a discovery that has sent shockwaves through the astronomical community. This is not just a data point, it's a clarion call from the universe, challenging everything we thought we knew about our galactic neighbor and our place within the vast cosmic tapestry. Chapter 1: The Dawn of Cosmic Curiosity. The story of Andromeda begins long before telescopes, in a time when humanity's understanding of the heavens was limited to what the naked eye could discern. In the 10th century, Persian astronomer Abd Arrahman al-Sufi peered into the night sky and recorded a faint cloudy patch in his book of fixed stars. Without the aid of lenses or mirrors, he described what we now know as the Andromeda Galaxy, a smudge of light that hinted at worlds beyond our own. To al-Sufi, it was a curiosity, a celestial oddity in a universe thought to be centered on Earth. Centuries later, in the 17th century, Galileo Galilei turned his rudimentary telescope toward the Milky Way and shattered the prevailing view of the cosmos. The hazy band of light that stretched across the sky resolved into countless stars, each a sun in its own right. This revelation planted the first seeds of doubt. Perhaps the Milky Way was not the entirety of the universe, but it wasn't until the 1920s that the true scale of the cosmos came into focus. Thanks to Edwin Hubble using the 100-inch Hooker telescope at Mount Wilson Observatory, Hubble observed distant objects beyond the Milky Way's borders. Among them was Andromeda, a galaxy in its own right, separate from our own. His discovery was a seismic shift, expanding the universe from a single island of stars to a vast archipelago of galaxies. Andromeda, or M31, became a cornerstone of this new cosmic perspective. Located 2.537 million light-years away, it is the closest spiral galaxy to our own, a twin of sorts. The Milky Way, its spiral arms stretching roughly 220,000 light-years in diameter, cradle an estimated 1 trillion stars, far more than a Milky Way's 200 to 400 billion. For decades, astronomers studied Andromeda through ground-based telescopes, piecing together its structure: a bulging core surrounded by rings of dust and gas, sites of fervent star formation, a halo of globular clusters, planetary nebula, and satellite galaxies. Yet despite these advances, Andromeda remained a distant enigma, its secrets locked away by the limitations of our instruments. Chapter 2: The Eye of JWST entered the James Webb Space Telescope, launched on December 25, 2021, and positioned at the second rangy point 1.5 million kilometers from Earth. Unlike its predecessor, the Hubble Space Telescope JWST is designed to peer into the infrared spectrum, capturing light that has traveled billions of years to reach us. Its 6.5-meter mirror coated in gold is a technological triumph capable of resolving details that were once mere blurs in a cosmic canvas. For astronomers, JWST is more than a telescope, it's a time machine, a window into universes past, and a tool to probe its deepest mysteries. In early 2025, JWST turned its gaze toward Andromeda, its sensors trained on the galaxy's core. What it found was nothing short of astonishing. Deep within M31's heart, where a super-massive black hole was believed to reside, the telescope detected a signal unlike any recorded before, a burst of activity that defied previous observations. This wasn't a steady hum of a dormant black hole or the expected glow of star-forming regions. It was something new, something that suggested fundamental processes at work, processes that could reshape our understanding of Andromeda and by extension our own galaxy. The signal was multifaceted, a cosmic symphony of light and energy. JWST's infrared sensors revealed unprecedented details, spectra indicating new star formation, chemical compositions that hinted at complex processes, and gravitational anomalies suggesting the presence of dark matter in unexpected distributions. Most startlingly, the data suggested that Andromeda's supermassive black hole was far more active than previously thought, its influence rippling to the galaxy's core and beyond. This activity could be sculpting Andromeda's structure in ways we hadn't anticipated, potentially linked to a double cap outflow, a rare feature hinting at a dynamic interplay of matter and energy. Chapter 3: Rewriting Andromeda Story. The implications of JWST's findings were immediate and profound. For decades, astronomers had estimated Andromeda to be significantly larger than a Milky Way, its mass dwarfing our own galaxies, but the new data painted a different picture. Refined measurements suggested that the size gap between Andromeda and the Milky Way was narrower than previously thought. The two galaxies, one seen as a giant and its smaller sibling, were now revealed to be more akin to equals. This revelation for scientists reconsider the dynamics of the local group, the collection of galaxies that includes the Milky Way, Andromeda and their smaller satellites. The updated measurements came from JWST's ability to capture high-resolution images and spectra by analyzing the motion of stars and gas within Andromeda. Astronomers could better estimate its mass and structure. The galaxy's diameter, once pegged at 220,000 light-year, was confirmed, but its mass was now seen as closer to Milky Way's, suggesting a more balanced rivalry. This shift had implications for the anticipated collision between the two galaxies, expected in roughly 4 billion years. A more evenly matched merger could mean a different outcome for the resulting elliptical galaxy, with consequences for the fate of our solar system beyond its size. Andromeda's core held other surprises. The supermassive black hole at its center, estimated to be 100 to 200 million times the mass of our Sun, was exhibiting heightened activity. Jets of material, possibly the double-capped outflow detected by JWST, suggested that the black hole was accreting matter at a rapid pace, sending shock waves through surrounding gas and dust. This activity could trigger bursts of star formation, altering the galaxy's evolution and providing clues about the role of black holes in shaping galactic structures. Chapter 4: The Dark Matter Enigma. Perhaps the most tantalizing aspect of JWST's findings was their implications for dark matter, the mysterious substance that makes up roughly 27% of the universe's mass energy. Dark matter doesn't emit or absorb light, making it invisible to traditional telescopes, but its gravitational effects are profound, shaping the formation and movement of galaxies. By studying the orbits of stars and gas and Andromeda, JWST provided new data on how dark matter is distributed within the galaxy. The telescope's observations suggested that dark matter might be more concentrated in certain regions of Andromeda than previously thought, particularly around its core. This distribution could influence the galaxy's gravitational dynamics, affecting everything from star formation to the orbits of its satellite galaxies. Understanding dark matter's role in Andromeda is crucial, as it offers a window into one of cosmology's greatest mysteries. What is dark matter and how does it govern a universe's evolution? The data also shed light on Andromeda's halo, a vast corona celestial material extending hundreds of thousands of light Years this halo contains stars planetary, nebula and over 460 globular clusters. Dense spherical collections of stars that are among the oldest objects in the universe. By analyzing their motions, astronomers could infer the presence and distribution of dark matter, piecing together a more complete picture of Andromeda's structure and history. Chapter 5: A Galaxy in Motion. Andromeda is not a static entity, is a living, evolving system shaped by billions of years of cosmic interactions. Its spiral structure with its bulging core and rings of dust and gas is a testament to its dynamic nature. The galaxies, satellite galaxies, more than 20 smaller systems orbiting M31, add another layer of complexity. Some of these satellites are being tidally stripped, their gas and stars siphoned off by Andromeda's gravitational pull in a process known as galactic cannibalism. This phenomenon highlights the aggressive side of galaxy evolution as Andromeda grows by consuming its neighbors' JWSTs. Observations also hinted at possible transformation in Andromeda's structure. Some astronomers speculate that the galaxy may be evolving from a classic spiral into a ring galaxy, a rare configuration formed through interactions with other galaxies. Such a transition would suggest a history of near misses or collisions, reshaping Andromeda's arms into a distinct ring of stars and gas. This hypothesis, while speculative, underscores a galaxy's dynamic nature and the ongoing processes that define its evolution. The most dramatic chapter in Andromeda's future lies in its inevitable collision with the Milky Way. In approximately 4 billion years, the two galaxies will merge their gravitational dance, culminating in a cosmic spectacle. This event won't involve direct collisions between stars. The distances between them are too vast, but the gravitational forces will reshape both galaxies. Gas and dust will collide, triggering bursts of star formation that will illuminate the night sky of any observer still present in the distant future. The result will be a single elliptical galaxy, a new entity born from a union of two spirals. Chapter 6: The Fate of Our Cosmic Neighborhood. The merger of Andromeda and the Milky Way raises profound questions about the fate of our solar system. While the chances of stars colliding are negligible, the gravitational upheaval could perturb orbits of countless stars, including our Sun. If Earth's distance from the Sun shifts significantly, it could alter our planet's climate, potentially rendering it uninhabitable. However, such changes would unfold over millions of years, far beyond the lifespan of humanity as we know it. The supermassive black holes at the centers of both galaxies are also expected to merge, forming a single more massive black hole. This process could release tremendous amount of energy, including gravitational waves and radiation, as matter is consumed by the newly formed behemoth. Studying Andromeda's active core today provides a glimpse into forces that will shape this future event, offering insights into the life cycles of galaxies and the role of black holes in their evolution. The local group, which includes a Milky Way, Andromeda, and dozens of smaller galaxies, will also be transformed by this merger. The orbits of satellite galaxies may shift, and some could be ejected from a group entirely. Understanding these dynamics is crucial for predicting the long-term evolution of our cosmic neighborhood and the forces that govern galaxy clusters across the universe. Chapter 7: A Ruckus Among the Stars. The JWST's discoveries have sparked a frenzy of activity among astronomers worldwide. Research teams are poring over the data, running simulations and proposing new observations to confirm and expand on the findings. The signal from Andromeda's core has become a focal point, with scientists debating whether it stems from the supermassive black hole, a hidden anomaly, or an entirely new phenomenon. Each piece of data is a puzzle piece helping to assemble the story of Andromeda's past, present, and future for the public. The news is both Thrilling and humbling Andromeda, once a distant smudge in the sky, is now a vibrant complex system that challenges our assumptions about the universe. Its similarities to the Milky Way make it a mirror for our own galaxy's fate, while its differences, its active core, its vast halo, its satellite galaxies offer a wealth of new questions. Why is the black hole so active? How does dark matter shape the galaxy's evolution? What will the merger with the Milky Way mean for the cosmos? The JWST's findings also underscore the power of human curiosity and technology, from Al-Sufi's naked eye observations to Galileo's telescope, from Hubble's revelations to JWST's infrared gaze. Each step has brought us closer to understanding our place in the universe, expanding our understanding of life, trillion stars, and enigmatic humanity. Is a reminder that the cosmos, the breakthroughs made by instruments like the James Webb Space Telescope, could redefine our comprehension as a JWST. Potential implications of discovering life beyond Earth. Scientific curiosity profoundly reshape our philosophical focus, confirming the existence intelligent life elsewhere. The notion that Earth observation adds to our understanding of pushing humanity to reconsider it and mysterious role of dark idea of encountering brings us closer to answering the liquid water could still exist on what is our place in the cosmic, despite the potential for the extreme conditions, such as high energy, as we stand on the presenting further challenges for the existing, although proximing, candidate for study and a marvel wonders of the cosmos in 4 billion years. When the Milky Way and Andromeda merge, humanity may be a distant memory, our planet a speck in the cosmic dance, but the knowledge we gain today through instruments like JWST will leave a legacy, a testament to our desire to understand the universe and our place within it. Andromeda's signal is more than a scientific curiosity, it's a call to look up, to dream, and to keep reaching for the stars.